Oceanography News.
Knowledge of the oceans is more than a matter of curiosity. Our very survival may hinge upon it.
Welcome to Ocean News 14. Our first story this week comes from USGS, U.S. Geological Survey, regarding the powerful earthquake that struck off Russia's Kamchatka Peninsula. July 30th, 2025, a magnitude 8.8 earthquake rocked the seafloor east of Kamchatka, making it the largest earthquake since Japan's 2011 Tohoku disaster, and among the top 10 largest earthquakes ever instrumentally recorded. This wasn't just a single point on a map. USGS modeling shows the quake ruptured a fault zone roughly 500 kilometers long and 150 kilometers wide, caused by the massive Pacific plate diving beneath the North American plate in one of the fastest subduction zones on Earth. USGS map showing past earthquakes along the Kuril-Kamchatka Trench, where the Pacific plate subducts beneath the North American plate. A red star marks the epicenter of the July 30th, 2025 M8.8 earthquake near the Kamchatka Peninsula. Circles of different sizes and colors represent past earthquakes, with larger circles for larger earthquakes.
Tsunami alerts in force for millions throughout the Pacific region. The tsunami threat triggered by a massive 8.8 magnitude quake that struck Russia's Far East hours ago. The first waves hitting Russia and Japan, where nearly 2 million people have been evacuated. This is video from Japan's second biggest island, Hokkaido, where people fled to the highest rooftops that they could find.
Communities of strange, extreme life seen for the first time in the deep ocean. Beds of clams, mats of bacteria that look like ice, and fields of tube worms. These are just some examples of the strange, extreme life that an expedition to the deepest parts of the ocean has observed, filmed, and photographed. Diving in human-occupied submersible to ocean trenches in the Northwest Pacific Ocean, a Chinese-led research team captured pictures of life at depths of more than 9 kilometers, 5.6 miles. The deepest marine vertebrate life filmed before this expedition was at 8,336 meters, a snailfish that was filmed swimming in a deep ocean trench off the coast of Japan in 2023. The new observations are published in the journal Nature. Scientists photographed what looked like fields of long, thin tube worms. The white spiky creatures are called mecellocephaloids grandicera. They are photographed in dense colonies of tube worms that can be up to 30 centimeters in length. Here we have some video of these deep sea life creatures found for the first time ever. Although it was accepted among marine scientists that there would be life at these depths, scientists on this mission say the abundance of animals they saw from the windows of their submersible was amazing. The scientific expedition covered more than 2,500 kilometers, exploring trenches at depths ranging from 5,800 to 9,533 meters. Researchers traveled in a submersible vehicle called Fenduze, which can operate at depths of more than 10,000 kilometers for several hours at a time. The team, led by researchers from the Chinese Academy of Sciences, Institute of Deep Sea Science and Engineering, discovered what they described as thriving communities of creatures. Findings challenge long-standing assumptions about life's potential at such extreme depths and pressures. They also suggest that these communities of animals, rather than extreme rarities, are actually widespread. Professor Andrew Sweetman, a senior scientist from the Scottish Association for Marine Science, told BBC News that the discovery showed the whole ecosystems driven by methane may exist in the deepest parts of the ocean. And how did it feel for a scientist to descend to such extreme pitch-black depths? Dr. Drew told BBC News, "Some people might find it frightening, but I always encourage my students, look through the window at the bottom of the sea," she said. "You will be inspired." It's exciting, especially for a deep-sea scientist, to go to a place that human beings have not explored. One of the lead researchers, Dr. Xiaoteng Peng, told BBC News. "It's a great opportunity to discover new things, and what we saw was quite amazing." Scientists photographed and filmed what looked like fields of marine life, dominated by various different types of tube worm and mollusk. These animals live in the pitch dark and under vast pressure. With no sunlight, life at these depths is fueled by chemicals that seep out of the ocean floor. Hydrogen sulfide and methane seep out of the faults or cracks in the Earth's crust. The scientists say they've recorded species never seen before. In future studies, they hope to work out how the bodies of these so-called chemosynthetic or chemical-fueled creatures convert these chemicals into energy. They must also have a trick to adapt to life in super high pressure, added Dr. Megron Du, also from China's Institute of Deep Sea Science and Engineering. That's another question we need to answer. At a Woods Hole Oceanographic Institution, going with the flow isn't just a saying, it's a way of life for baby corals. In their juvenile stage, corals drift on ocean currents until they find a good place to settle. Even in the deep sea, our researchers study ocean dynamics to better understand how reefs are connected by invisible ocean currents. Millions of tons of nanoplastics are polluting the ocean. These plastic particles, smaller than a human hair, can pass through cell walls and enter the food web. This is an image of an underwater view of a free diver diving in coastal waters full of plastic waste. Marine plastic litter tends to grab headlines, with images of suffocating seabirds or bottles washing up along coastlines. Increasingly, researchers have been finding tiny microplastic fragments across all environments, from the most densely populated cities to pristine mountaintops, as well as in human tissue, including the brain and placenta. A study published today reveals yet another hidden source of this deadly waste. Nanometer-scale particles are literally everywhere, says co-author Dusan Meterik, an environmental analytical chemist at the Helmholtz Center for Environmental Research in Leipzig, Germany. Meterik and his colleagues sampled water at 3 depths representative of different environments in the North Atlantic Ocean. Throughout the water column, they found 3 types of nanoplastic. All are impossible to pronounce. They are PET, PS, and PVC. These were present at average concentrations of 18 milligrams per meter cubed, which translates to 27 million tons of nanoplastics spread across just the top layer of the temperature to subtropical North Atlantic. Nanoplastics make up the dominant fraction of marine plastic pollution, Meterik says. In the entire world's oceans, it is estimated that there are around 3 million tons of floating plastic pollution, excluding nanoplastics. What are plastic nanoparticles and how are they different from microplastics? The tiniest pieces of plastics, nanoplastics, are defined by the researchers as having a diameter of less than 1 micrometer, 1/1000th of a millimeter. Microplastics are between 1 micrometer and 5 millimeters across. At the smaller scale of nanoplastics, materials behave differently. Meterik and his colleagues found that the particles were distributed throughout the water column, rather than settling to the bottom. The movement of the nanoplastic particles was dominated not by gravity, by the random movement called Brownian motion, and by collisions with water molecules. How did the team find the nanoplastics? The scientists took water samples during a November 2020 cruise on a research vessel, Pelagia, which is owned by the Royal Netherlands Institute of Sea Research in Texel. They sampled at 12 locations, 5 in the system of circular currents called the North Atlantic Subtropical Gyre, 4 in the open ocean, and 3 from coastal areas on the European continental shelf. At each location, they gathered samples at depths of 10 meters and 1,000 meters below the surface, and then 30 meters off the ocean bottom. The nanoplastics were detected using a technology called thermal desorption proton transfer reaction mass spectrometry. We faced multiple challenges, said Materik, including the need to remove contaminants other than the nanoplastics. Each 10 millimeter sample was run through a filter with micrometer pores to clear out microplastics. Samples were then slowly heated, releasing any organic matter and allowing the remaining plastics to be identified. Not all was as expected. We faced a big mystery, says Materik. One of the major class of plastics, polyethylene, PE, was missing from the data, even though fragments almost certainly enter the ocean. The fragments probably transform into something else, or might fall into the seabed, says Materik. This suggests that PE nanoplastic cycling in the ocean environment follows some unusual pathway, either rapid chemical alteration or mineralization or fast sinking. Should we be surprised or worried about this source of plastics pollution? This does not come as a surprise to me, as I've been aware of the extent and magnitude of the problem for some time, says Tony Walker, an environmental scientist at Dalhousie University in Halifax, Canada. Nanoplastics, unlike microplastics, are able to pass through cell walls, meaning they are already incorporated into the ocean phytoplankton, which serve as the base of marine food web and are able to transfer through the marine food web, he explains. The ubiquitous of nanoplastics means that they should be taken seriously, says Materik. Given their toxicological potential, they may represent the most problematic plastic-sized fraction for ocean life, he says. Walker agrees. This should be a wake-up call to all of us, he says. The extent to which nanoplastics can infiltrate every ecosystem and living cell on the planet is even far worse than we already know about microplastics and larger plastic pollution. What can be done to mitigate the pollution? The next and likely final round of negotiations for a legally binding United Nations treaty on plastics pollution will kick off in August in Geneva, Switzerland. On the table is a limit on future plastic manufacture, but this is being resisted by some countries, including those that rely on oil and gas exports to power their economies. One of the best strategies to mitigate future nanoplastics pollution or release into the environment is to cap plastic production, says Walker. Turn off the tap. Thank you so much for watching this episode of Ocean News. Make sure you smash the like button, hit subscribe, turn on notifications, but also, more importantly, visit d-2.com, hit our news tab, and bookmark that so you never miss out on any of these important news updates.
Knowledge of the oceans is more than a matter of curiosity. Our very survival may hinge upon it.